Welcome to this presentation. I'm going to talk to you about the project I've written, which is named config model. And I will talk about how it can be applied to configuration upgrade during package upgrade. But before going to configuration upgrade, I will explain you why config model is the objective of this project, the basic usage and principles of config model, and then how it does apply to package upgrades. So, how many of you have installed a Debian Linux system for your friends, or families, neighbors, and so on? Okay. How many of you does administration? Why? Is that configuration is part of the project configuration of the software installed? For a casual user, like my mother-in-law, I've installed also the Debian system for my mother-in-law. Configuration, she cannot do it. She won't, she doesn't understand it. So I have to do the administration. So I was thinking, why couldn't we make the configuration easier with the GUI, the helps, and so on? So that's why I've created this software. So for a casual user, upgrade is even more difficult. Sometimes you have a surprise question. For instance, in Debian with the UCF, you can be asked, do you want to keep your own version of the configuration? Do you want to keep the maintainer's version? What is a maintainer, by the way? And do you want to merge or show you a diff? What is the diff? It's complicated. And then I have to go to the documentation to see what's going on and to actually modify the configuration file. So a very usual configuration upgrade for casual user is very difficult. Even worse, sometimes you have to edit a file outside of your own home directory. What goes outside of home? It's very difficult. I have to read man pages, tons of man pages. Very difficult to understand. Even worse, sometimes I have to ensure consistency between configuration files. If I set something here, it will be reflected in another configuration file. So it's also difficult for casual users. And then you have spurious files. I won't use the words that Jeff used the other day. On your system in /etc, you have rpm save, rpm new, dpkg old, dpkg new, all lots of files which can be left there. And if you want to manage your configuration, you will have to merge them manually or remove them manually. Even basic configuration will also be difficult. I've talked about this sooner. So one of the objectives of config model is make the configuration upgrade mostly transparent to the user, no interaction. So the system should handle most, if not all, configuration upgrade during package upgrade. But sometimes we will still have a user will still have to configure the system. So I provide a graphical interface with integrated health, meaningful default values, validation, semantic validation of configuration data, even if there are a relationship between parameters. Several level of skills like on the XIN configuration interface where you can be beginners or up to master of the universe. So I was more modest, it's just beginners to master. And provide a search capability to search in parameters, to search in the parameters value, or even I thought recently about searching in the integrated help. So if you hear something about a configuration and have a keyword, you just search for the keyword, and the interface will guide you towards the right parameter. Second objective, do not put all the work of the developers on the package maintainer. See, it's a configuration tool and the configuration tool and the upgrade mechanism must be easy to maintain in order for the developer to adopt them. So I want to avoid dedicated validation code. Dedicated validation code is hard to write and almost impossible to maintain. I want to base the validation on some kind of metadata, which is a configuration model, which means all the specification of what's right or wrong in the configuration is written as a data structure. It could be a DSL, currently it's a data structure. I want also to generate interfaces. Currently I generate graphical interfaces, cursive interfaces, and you can also interact with the config model with command lines. and interactively, like if you were on an old modeling line or on a Cisco system. Models are also specified to provide, to help, to perform the upgrade of configuration from old version to new version by migrating all relevant data from old syntax to new, old semantics to new semantics. Given the talk that was before, I'm beginning to think about ways to perform also rollback of configuration. We can go in from configuration N to older configuration using old syntax and old semantics. So I will have to think a little bit more about this because it's tougher than just doing upgrades. And also for the developers, not to be, for the developers' work, maintainers' work, the maintainer of the model works to be not too hard. I've provided also, sorry, a GUI to create and maintain the configuration model. Also, the model is not everything you need. You also need some way to write and read and write configuration files. So I've tried to minimize the code needed to read and write configuration files. So I use sometimes the existing library like any config.OJS behind config.OJS, which is a very good project to read and write configuration file. So, and also I provide basic classes to help configuration. If you have to be a write dedicated code, like OpenSSH, for instance, I've written a class to read and write OpenSSH files. I've provided basic class to help this. So it's just a reader and parser to just read the data, put it in the configuration tree, and that's it. Okay, so here's the basic design, in fact. I've talked about the model here. So in blue, in brown, it's provided by config model. In blue, it's provided by the upstream maintainer or the distribution, the guys who create the model and who create the configuration tool. And in green, it's provided by the user. So by the work of the Debian upstream maintainer or Debian packager will be to create a model, create the writer, and create the reader, or reuse the relevant libraries. Config model will use the model to create the several interfaces. Here the command line interfaces, cursor interfaces, web graphical interfaces. And I've thought about web interfaces, but I didn't have time to do it. Help would be welcome there. On the other side, the application here, you have the configuration file which will be read by the reader or written by the writer, depending on what's stored in the configuration model, and depending on what was entered by the user on the interfaces. If you have questions, feel free to ask me. So what is a model? First thing to understand is most configuration data in configuration file can be represented as a tree structure. Sometimes you have more complex relations in the tree, but let's start with simple. Configuration is a tree, a bit like an XML file. So you have to define, in order to validate the configuration, you have to define what's in the tree, what is the structure of the tree, and what values which are represented in the list, what are the values and constraints of the value. So the model defines the tree structure. A class represents a node of the tree. A configuration class represents a node of the tree. For instance, here you have the SSH class, which is the root node of the SSH configuration. And a parameter is represented by a leaf. A leaf is just in this here. A leaf will be stored, will be shown as an element of the SSH configuration class. These are other parameters to help. Here you can see the read config and write config, so you specify how to read and write here. So each class contains a set of elements, here highlighted, which represent the parameters, and optionally specification to read and write configuration. I said optionally because read and write specification is mandatory for the class that represents the root of the tree, but is optional for other nodes. So it's a way to be able also to store, use the configuration tree to store them in several configuration files. Okay, so here it's a snapshot of the GUI to create configuration model. So simple element, each element has a type. It can be a simple list, so it's a simple parameters, or it could be a hash, It's a parameter which can have several keys and several values. It could be a list, because there are no notion of keys or to access this parameter. Or it could be another node, which means you have a complex tree structure with several levels. Each list can have constraints, whether it's a type, whether it's an integer or a string, maximum value, minimum value, mandatory, not mandatory, and so on. Default values. There are several types of default values. There are default values which are embedded in the application. Where I talk about upstream default, there was a big discussion with Stefano Zeccarelli. I don't know if he's here. And upstream default means the application node of the default value is encoded in the application, so you don't have to write in the configuration file. But the default value will be written in the configuration file. The default value can be required, for instance, by Debian policies. For instance, in Debian policies or Debian recommendation, the permit root login of the SSHD server is always set to no. So this is an example of a default value. Whereas for the permit root login value for upstream default is yes, because the SSHD by default permits root logins. There is also in the model a description and a summary for to help people for integrated help, or maybe you could imagine generate reports of what's in the configuration, mixing the integrated help, which is the description of the parameter with the actual value. All lots of things are possible here. You also have the experience level, the skill level, beginners to master, and a status. Which the status is the first step to be able to manage upgrades with config model. So you have the normal status, which means it's the regular parameters, and you have obsolete. Okay, it's on its way out. Config model still don't understand it, but the application may not understand it. And the obsolete parameters with an obsolete status is often should be reused by another parameters during the migration, the upgrade process. I will talk about this a little bit later. Here on the right, you still have the GUI of the model creation tool. Okay, so what work do you have to do to create a model? First, you have to read the documentation in order to find the structure of the tree. How is the tree structure? It's not always obvious just reading the configuration file. For instance, with SSHD, you have the impression it's just linear, but with the match derivative, in fact, you define another class because the match will apply on a set of hosts, and all the parameters below the match declaration will apply to this host. So SSHD looks flat, but in fact, it's hierarchical. So, and you have to identify the configuration parameters, the constraints, and the relation. This process was described in Linux magazine France, and unfortunately for most of you in French last year. So if you want to learn more about this, you could also read Linux magazine France. And then also, after that, you have to find several valid examples of the configuration file, because it will help you verify that you correctly understood the documentation, which is not so easy most of the time. And it will be helpful for the non-regression test of your model. Okay. In short, in fact, the configuration documentation that we will read in the web pages will be translated in the format understood by a config model. Tree structure is translated into a set of configuration classes. The configuration parameters which belong to the classes that you have identified will be in two elements. And constraints are elements attributed here. So for instance, the SSH class, in the SSH config of your .ssh file, you have enable SSH key sign parameters, which is the element's name, and it's an element. So here I've shown you the data structure which is generated by the GUI. It fits more nicely in the slides than the GUI, so that's why I've written here. But you will find this in the GUI, this in the GUI, and all this in the GUI also. So here what we have is the class SSH. We have a parameter enable SSH key sign, which is a leaf, and which is a boolean. And the default value understood by the application, the SSH client, is 0. So if you don't specify anything, it will be 0. And then you have a description. If you want more information on model creation, I've written a wiki page on the SourceForge wiki of the site. Okay, so writing the Perl data structure is not fun for most people, even for Perl developer. Big data structure are not fun to write. So that's why I've created the GUI of, that enables you to specify models. So here you read, you see, or you don't see the class SSH element, enable SSH key signs, the type if, the value type boolean, and so on. The green arrow means that the value was entered by the user. It's not the default from the application itself. So here, there were 3 parameters entered by the users, and there is a description below. So this matches the data structure I've shown you just on the slide before. Any question on the model declaration? Yes?
Why are you using code instead of markup to define the declaration?
You mean on the slide I've shown you before? Because this code is used inside config model. I could use markup. It's a... Yeah. Anyway, I need something which is structured, so the code is easy to parse and very fast. I could use XML or something else, and it could be exactly the same methodology. Okay, so when you create a model, you have also to think about the future configuration upgrade. The first thing is to avoid introducing new parameters. It may be obvious, but often beginners tend to abuse of configuration parameters, so don't. Avoid at all costs. But sometimes you still have to introduce new parameters. First, think really hard about the parameter name and its value. Meaningful parameters and meaningful value are is a great help, and it will avoid you writing lots of documentation and explanation mails. So think really hard about the new names and the new values, the possible values of the parameters. Then provide default values, so the application can work with an empty configuration file. By default values, in this case, I mean written inside the application. Or, if you need, provide them in the model. In the model, when you apply the config edit command, all the default values will be written in the files, and the user will see nothing. It will be as if the default value were understood by the application. So it's a way out, but you must provide default upstream values or default values. Then the configuration upgrade will be transparent. If you provide the mandatory parameters without default value, the user will have to step in to configure it. So that must be avoided. So if needed, model and backend, which backend is the name for read and write backend classes. They can specify how to replace a value. If you want to change the value from a non-meaningful name to a new meaningful name, a config model can take care of this for your user during the upgrade. You can specify obsolete parameters. If you want to get rid of badly named parameters, you can put its status to obsolete, and then you have to specify how to migrate it from the old parameters to the new one, using the migrate from parameters. And you can use a formula, so you have to put a more complex migration than just copying value. For instance, if you want to have a configuration file with imperial metrics and you want to go for 2 meters, you can use multiply by something in a formula to change the values from imperial metrics into metrics, regular metrics. Well, apologies to American people. By playing with the backends, because you can specify several backends which will be tried in sequence, you can also migrate a value from one syntax to another. For instance, if you have an old ini file, you can read it with the init backend and save it back as XML. So you can change completely the syntax of a file if you want to go for a project version 2.0 with XML configuration. With this, you could migrate the old configurations to the new one. For more information, I've written a paper on Debian Wiki on how to apply config model for Debian packages upgrades. It's still a work in progress, but I think it's promising, and I got lots of people interested. So in the end, what the user will see, here's the configuration GUI that the user will see. You will see here the SSHD class will with the allow user parameter, allow TCP forwarding, log level, max fast stop, and so on. So this is the GUI, SSHD GUI that is shown to the user. And this is generated from SSHD model as well. So here you see that I've changed the log level, which is verbose instead of info. And here the permit root logging, which is no instead of yes. And okay. And here you have the value of the highlighted. Here you have the values info, which gives you the type of the parameter, which is an enumerated type, which is yes, first come password, without password, stuff like that. And the built-in value in the application, the built-in default value is yes. And here's the description. And this is generated from the model. By the way, okay, does any of you know why this GUI looks like the GUI of the configuration edition tool? Because I've written a model of config model. I've eaten my own dog food. The name of the module, if you're interested in looking at it, but don't do it first, it's a config model itself. Okay, package upgrade. What's the status? On Red Hat configuration evolution may leave some RPM new or RPM save files, and then you may need to merge them manually with your actual configuration. On Debian, configuration will either trigger questions, which are often pretty generated by USCF. Do you want to keep your file, use a diff, do something else? Or you can also have spurious file like RPMCF, but now it's depicted in new files. In all cases, matching configuration will require good knowledge from your user, and that does not apply to my mother-in-law. So that's why I've created config model. Okay, so here's the proposal. Config model can be used to merge user data from the old configuration file, and you can also put package and upstream resolution inside the model using the migration, the obsolete status, and so on. So the evolution of the model of the configuration can be written in the model, specified with the status obsolete and migrate from parameters. So once you have defined these models with the migrate instructions, the obsolete stuff, it can be applied to the configuration to migrate the old configuration into the new one. The merge capability can be either implemented by upstream project. If SSH do some changes, the more changes will be reflected in the model. The model can be patched, modified by distribution during the build process, or when they do their packaging work. It can be also modified sequentially by derived distribution like Nopix or Skull Linux. So each level of integration that you have here from upstream, downstream, can improve the model and tune the model to its own needs, to the own needs of the distribution and the needs of the users. Again, it's the same proposal on package config upgrade. So here's an example. Still, I use the data structure instead of the GUI. It's more clear, and I can without also what's not modified. Here's the old SSHD parameter, which is named keep alive. The main doc mentions that TCP keep alive was named keep alive before. So here's a real use case. Keep alive is an enumerated type, and the choice is no or yes. I don't use a boolean because SSHD specifically wants yes and no, and not just 0 or 1. So it's a way of doing it. Status is deprecated. It's almost obsolete. I need to clarify it. And the type is leaf. Okay, so this is the old parameter, what was contained in the old model. When I write the new model, I introduce the new TCP keep alive parameters and I specify how to migrate it. So again, I have the value type, the type leaf, and the choice, which is yes or no. And here's the migrate from specification. Here I define a formula and variables. Variables means they refer to other parameters in the configuration tree. And this is what is complicated. You have here where to find this variable. I go up one level in the configuration tree, so I go in the SSH class, and I use the value of keep alive. This is stored in this keep alive variable, which is used here in the formulas. Here the formula is very simple, just put keep alive in there. So in fact, the two lines specify that the default value of TCP keep alive is compiled from keep alive directly. And when the configuration file is saved back on the system, the status deprecated means that this one will not be written, and since this one has a default value calculated from migrate from, it will be written back in the configuration file. Of course, more complex migration scenario can be used with the formula, and you can have several variables, so you can mix parameters in order to perform a migration for very hairy cases. Question on the migration? Yeah. You can use a full Perl expression if you use Perl. There is another parameter which is named useval, but I didn't want to force Perl on everybody. But it's possible. Okay, practically how this can be done? For Debian, I've written a dhconfig model grade, and this is just the line you have to add in your Debian rules file. Just specify the model name that must be used to perform the upgrade, the name of the package which will require it. In this case, the name of the package that contains the model, the libconfig model SSHD Perl. And by default, this will apply to all the packages built with OpenSSH, which needs to be refined a little bit, but there are the mechanisms. For Red Hat, I don't have any Red Hat helper, so the trick is to run post-install this command, which will use model SSH, specify not to use any UI, no user interface, and force the save of the configuration. I say force the save because here the user does not enter any parameters, but just the thing to be done is to upgrade. So the save will rewrite the file back using all the migration parameters that are declared in the model. If there is no migration parameters in the model, the file will be written back with the exact same semantic content. Okay? Basic config model does not keep comments. If you use OGS backend, you can keep comments. But for the tries I've made for upgrades and so on, as soon as you add new parameters, you don't know where these new parameters will be introduced, so the comments can kind of get messy. But it can work with OGS. Okay, what models are available currently? We have I have written OpenSSH, Eprox, which is Debian cache server for Debian packages. Config model in config model itself. I've written Kerberos in XOR in the little because Kerberos was written by one guy, but I just have the model and he no longer works in it. And XOR, I've written a model for XOR 1.4, but XOR is moving too fast for me to catch up. So XOR does not work anymore. Maybe I will have some time to do it. Backends, you have ini file syntax with those ini files, Perl data structure. I'm currently working on YAML, and there's a whole OGS library which can be used from config model. Community Debian packages are. I maintain the Debian packages with Debian team with Gregor and John Z. RPM packages are under construction, are constructed. Non-Riva packages are done, and I've made some proposal to patch for the hconfig for package upgrade and so on. So I want to experiment this configuration upgrade with Debian. And there is an article in New Magazine, France, in French, unfortunately. Future projects, search parameters need to add this annotation, which means comments, but introduced through the GUI. The difficulty is where to store them. It's very difficult to store them in the file itself because it will mess up sysadmin comments. So I still have to think about this one. Backends, read and write parameters they need to work. Maybe a JSON or YAML will be similar. XML could provide XML quite easily. So I need people help. I need integration in this tradition, so it's done for Debian, must be done for Red Hat. I must work on multi-level configuration for Apache, for instance. plugin mechanisms, so several people can work on model and integrate them together. And define a mechanism for this configuration injection. For instance, so when you add a Mercurial viewer and patches, you will plug in a few bunch of configuration. And how to manage these configurations through config model, I don't know yet. I need to work on this. Here are the links for references. If I have time, I have a small demo. Yeah. Okay, so here you have a cat which is done every 2 seconds on my SSHD config. I've put the default parameters with keep alive and in your host to know, etc. So I want to keep to perform the grid I talked to you about change keep alive to TCP keep alive. So here we go. Let's click here. Sorry. Sorry for about that. Okay. Here we go. So I've run the config edit model I've mentioned. There is stuff in order to be able to catch the class locally and the configuration file locally and so on. But you see the UI node backend custom and save. So now you see that it tells you that keep alive was deprecated. And here the file you see that TCP keep alive was changed to TCP keep alive. Here I've not used OJS backend, so the commands are lost and the files reformatted. Okay. Now there is a new policy in Debian. I want to set permit root login to no in all the configuration file of my users. So I patch the model with config model edit. So here I introduce the class SSH, the element permit root login. The default value is no. Okay, and the string default is set to with reset. So here I've patched the model. This could be done, for instance, at packaging when packaging a stream project. I will show you the difference in the model. I've prepared the demo, but okay, just this line upstream default was removed and default was added here. Upstream removed, default added here. So the model, you can see the effect in the data structure. Packager could either use regular patch mechanism or could use config and model edit. I think config model edit is safer, will be safer, more resilient to upstream change in the model. Now when I do the upgrade, permit root login is updated. Now you see the value was added and set to no without user interaction. And the old values are still kept. Okay, now another distro policy. I want to reduce the default cipher list. So again, I patch the model with config model edit, specify the class, the element cipher, the default list now is the AES 128 and so on, stuff like that. So the model will be patched again. So we can go. Okay, continue. We see effect on the file. Yeah, we see effect on the file here. We have the cipher list was updated in the configuration file. These configuration editions can be scripted also with a simple command like here. I will run config edit and set directly new parameters with ignore host equals yes. And the new parameters are in this configuration file. And what will the user see from this stuff? Here's the graphical configuration, the GUI, and here you can see the parameters that were just updated with the command line. And we see that it was updated. And if you want to change back, I get here, delete, I go back to the standard value. And then, save. Done. Here we go. Done. Yep, question?
Curious, so if I'm editing my mother-in-law's machine and I want to add a new parameter manually to this outside of config model, like X11 forwarding, yes, then you decide to issue a new update, will my manual change be maintained?
It will be maintained. Okay. The default values introduced by Debian policy will be written in the file only if there is nothing in it. If there is already something, some user data, the user data will be kept.
And also, it shouldn't be too difficult to just add a new key value parent configuration as like a comments flag, so that those comments are written and maintained, because those are certainly valuable.
Yeah, we could have some kind of convention to write comments and to be able to parse it. The problem is if there are random comments from sysadmin, I don't know how to treat them. Okay. So for the annotation, I was thinking about storing them elsewhere, but then I have to decide. Probably the best way would be to store them elsewhere and use the GS to keep the sysadmin comments in the configuration file and keep the annotation, which is comment in the GUIs, separately. That's possible. That's a possibility. I need user feedback on this. If it would be useful, I will implement it. If you think it's useful. Yes, question?
What does happen if some user or some administrator decides to change the configuration file in a way that is not covered by the model? How does the config model react to that situation?
It will exit on error. By default, it will exit on error. Our problem is how config model can know whether it's a new parameter, a non-parameter, or whether it's a typo. Okay.
I agree that it's a difficult problem.
Yeah.
I'm not sure if that behavior is the best one.
It's still the problem. I cannot decide whether it's right or new, whether it's wrong or new. I just exit. At this point, we might consider it's a bug in the model and send a request upstream or to the maintainer to update the model, because the model in this case will not have followed the upstream application. Yep.
Next question. On what packages are most are best suited for this config model, or which packages would you think it would make more sense or less sense?
All packages that have a regular, relatively simple configuration, like cups, Xorg is extremely limit. I know that Exim does not fit because Exim uses the DSL as a configuration language, and it's not a regular configuration file. It's a kind of description of the behavior of the application. And most of the application, I think, could go into config model. Even either server application like SSHD, cups, or user application clients, you could also handle a local configuration file in a .file in your home with it. And I don't know what are the limits, frankly. I think most of them, except the most complicated one and the most intricate one. It's whether you can find a tree structure in the configuration file, and then it's good. If it's not easily maintained in the tree structure, or if it becomes too complicated that using the configuration file is easier, then it's not good for this application. And Exim is a perfect example. -3 minutes, okay, I'm on the below the watermark. Okay. Another question?
It's in CPAN now.
Sorry?
It's in CPAN right
It's in CPAN and in Debian unstable. And probably in non-Priva, I don't know how up to date, and it's coming in Fedora. Just ask, for Fedora, ask Emmanuel Seman, and he will do it. Okay?